Assalamualaikum warahmatullahi wabarakatuh, and very good day to everybody. So now we move to our new chapter we have done in structure analysis. Basically in the statics, referring to our textbook is engineering mechanics statics, written by the R.C. Hibbeler. After the chapter 6 structure analysis, there should be chapter 7 is internal forces, and then followed by chapter 8 friction. But in our syllabus, because we are studying in the diploma, we are taking some topics from the statics and some topic from dynamics. So we didn't learn for the whole content of the static. We didn't learn the whole content of the dynamics. So after we complete the chapter 1 until chapter 6 from the R.C. Hibbeler engine mechanics statics, we have moved to the chapter 9. So we skip chapter 7 and 8 because 7 and 8 is not included in our syllabus. So we are taken only the chapter 9, center of gravity and centroid. Okay, so this chapter will be a last chapter in our static course. Then the next video we will move to a new subject of dynamics. Okay, center of gravity and centroid. Basically we have the two main objectives in our this chapter. The first one is to do the concept of the center of gravity, center of mass, and centroid. What will be a center of gravity, what will be a center of mass, and what will be the centroid. And then determine the location of center of gravity and centroid for a system of discrete particles and a body of arbitrary shape. Okay, the outline for this chapter is the only two. So first one, we need to learn about the center of gravity, center of mass for a system of particle. The next one is a composite body. Okay, for center of gravity and center of mass for a system particle, for example, we have the complex object. We have too many particles in the object. So we want to make a single weight. As I said last time when we are learned in the chapter 6 in the structure analysis, we have the internal equilibrium and rigid body. So all the weight of the particle is assuming as a resultant weight. So only consisting, for example, here you can see differential weight here. So in this one is have a rigid body. So this one is we assume is a larger mass, so larger object. So each part have the weight. Now we want to focus on their resultant weights, only W. This one differential weight means by they have only one of weight from total weight. So this one consists of the whole resultant, only one resultant weight. So this one is have many weight of the inside the system of particle, but this one just we are converting from the each one of the weight into only one single resultant weight. Okay, so consider system of n particle fixed within a region of space. This one is the region of space, n particles, too many particles, dw consists of one particle. So let's say we have n particles. So now the weights of the particle can be replaced by a single equivalent resultant weight. We have defined point G application. So when we are replace the total weight into one single equivalent resultant weight, so we need to define a point G of application. We need to the resultant weight is from the point G. This one is the center of gravity. This why we need to determine the center of gravity. So how you want to determine the center of gravity? So they have the coordinate from the x-axis, coordinate from y-axis as well as a coordinate from the z-axis. Okay. So as I said just now, the resultant weight is equal to total weight of n particles. So the WR is the resultant of weight. So it is equal to the total weight of the weight of n particles. So now we are recap back what we have learned in moment. So sum of moment of weights on a particle about x, about y, about z axis is actually the moment of resultant weight about this axis. For example, we have this differential x, differential w. So the moment about y here just multiply by this perpendicular distance x bar here. The x bar here is referring to this differential weight. So you have too many now we are replacing this W. So this W only the one X bar, but here too many weight multiplied by each one of their own X bar or Y bar, Z bar. So the summing moment about X axis, for example, the X bar you can hear is this one is X bar only for the resultant weight. This one X tilde is for the center, the location for the W1, X2 tilde for location for W2 as well, and until the Xn tilde until Wn particle. Okay, same thing with the summing moment about Y-axis. This one, the Y bar is a location for this resultant weight in the Y-axis. So it's actually equal to the sum of the moment. For example, W1 for respect to the Y1 tilde. This one is for the location for this Y1 with respect to the Y. And also the W2 from the Y-axis to the Y2 tilde until the Yn for Wn. Okay, so same thing for the Z-axis also. Okay, so we have the X, Y, and Z. So generally, so the X bar here, so when we are dividing the X bar, so this one the total weight here, so the total X multiplied by M dividing by the summation of M. Okay, so now when we from this summing moment here about X, about Y, and also about Z, so generally we have the X bar is summation of the X tilde into the specified of the weight multiplied by mass, and also dividing by the total resultant of masses. So this one is actually center of the mass or the center of gravity. So how we want to, why is the generally, so when we are dividing the WR here to so total summing moment here, so dividing by the WR here, so we get here. So how you want to derive? So what we did, the formula is given here. So basically, center of mass provided acceleration due to gravity G for every particle is constant, then W is equal to mg. So now this W is equal to m1 multiplied by G. So when we are, this one is the mr dividing by multiplied by G, so G is cancelled out. That's why the only the mass is remain. So by comparison, the location of the center of gravity coincide with the center of mass. So the location of center of gravity is coincide with the center of mass is equal. So particles have weight only when under the influence of gravitational attraction, where center of mass is independent of gravity. So it just coincide with the center of mass. Okay, so here center of mass. So a rigid body is composed of an infinite number of particles. Consider a arbitrary particle having a weight of dW here. For example, so the X bar is given by X tilde dW differential weight. So this one we can solving by using the differential equation or integration by integrate the dW. Okay, same thing with the when you're talking about the center of gravity or center of mass. So just dividing the weight by the weight of that particular object particles. This one the total particle, this one each particle. Then for the volume we are change, instead of the weight for the mass is a dW, for the volume it is dV. So just multiply by the volume, and also by area is a dA. So the same concept, same idea. So if you want to make the center of area, it's just a summing moment of area of a particle into that each their own X tilde here divided by the total area. For the volume, instead of the area we are using the volume. For the weight of gravity or the mass, instead of the volume or area we are using this W. Okay, I think we will stop here. We will see in the next video in a composite body. So see you again in next video. Thank you. Bye bye.